Welcome back, everybody. In this video, we're going to talk about multiplying and dividing integers. And the reason they're grouped together is because they actually use the same rule for determining if the final answer is positive or negative. So it's a good idea just to do them at the same time. So you want to make sure, again, as you're taking notes, just another reminder to put your title up top. I do also recommend you put the date in for the date that you're taking the notes, or at least the week in which you're taking the notes so that you can keep track of the class. And then also feel free as you're going through, of course, to pause the video, add in additional notes or comments if you hear me say something that you want to try to remember that I didn't write down, and even at the end. So once you finish your notes for the video, you may just want to pause and just take a minute or two, read through them and make sure you haven't missed anything before you move on. Or make yourself some additional notes or thoughts at the bottom of your page too, just little reminders for yourself. So do whatever is helpful for you. All right, so for multiplying and dividing, they have the same rule. So what you're going to see for multiplying is that if you have a positive number times a positive number, your answer is positive. And if you have a negative number times a negative number, your answer is also positive. Okay, so if you have the same sign, you end up with a positive answer. If you are multiplying a positive number times a negative number, you get a negative answer. And if you have a negative number times a positive number, you have a negative answer. So you're going to notice that if you have different signs, your answer is negative. So let's just do a couple quick examples here. So for instance, something like 4 times 3 is obviously still 12, but something like negative 4 times negative 3 becomes positive 12 as well. If I have positive 6 times negative 3, I end up with negative 18. Or if I have negative 6 times positive 3, I also end up with negative 18. Okay, so when you have the same sign when you're multiplying, you get a positive answer. When you have the different signs when you're multiplying, you get a negative answer. And dividing works the same way. So if you have a positive number divided by a positive number, you get a positive answer. You have a negative number divided by a negative number, you also get a positive answer. So if they have the same sign, get a positive. If you have a positive number divided by a negative, you get a negative. Or if you have a negative divided by a positive, you also get a negative. So let's say I have 12 divided by 2, I would get 6. Or if I had negative 12 divided by negative 2, I still also get 6. If I have 10 divided by negative 5, I have negative 2. Or if I have negative 10 divided by positive 5, I still have negative 2. Okay. Just as a little note here with division, let's say I wrote something like, so if I have negative 5 over 5, sorry, negative 10 over 5, that's the same thing as positive 10 over negative 5, which is the same thing as having a negative out front and 10 over 5. So you're going to see with division, it doesn't matter if you have the negative up top, down bottom, or out front, the final answer is still negative. If both of those are negative, then you get a positive. So if you have two negatives anywhere, you're going to end up getting a positive. But if you only have one negative, it doesn't matter if it's up top, down bottom, or just out front, you still get a negative answer there for division. And what I like to note here is that for multiplication and division, notice that negatives cancel in twos, right? So notice that anytime you have two negatives, they cancel to become a positive. Here, two negatives, they cancel to become a positive. Here, two negatives, they cancel to become a positive. So really, if you just keep in mind that with multiplying and dividing, if you have two negatives, they're going to cancel out, then you're all set. That's basically the general rule for multiplication and division here. Now, if you want to multiply more than just two numbers, then you're just going to take it two at a time. Okay? So let's say I have -2 times -8 times +1. Then you just take it piece by piece. So for instance, -2 times -8, those two negatives would cancel to give me +16. And then I have +16 times 1, which is just 16. Or if I have -4 times -1 times, I don't know, -3 times -2. So I can just take it from here. So -4 times -1 is going to be +4. And then here, +4 times -3 is -12. So because I only have one negative, it's going to stay. And then finally, if I keep going, my two negatives will cancel again, and I have +24. We just take it one little piece at a time. Now, as a shortcut here, again, a lot of students notice that negatives cancel in twos. So if you see two negatives, they're going to cancel. So kind of a little shortcut, what you can do at the beginning of a problem is just start canceling. So I see two negatives here, so I can just cancel them right out. And now that I see I have positive, 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 so my answer will be positive. Here, again, there's a pair of negatives, and here's another pair of negatives. So I can cancel those in two. Now I see I have no negatives left, so my answer is going to be positive. So same thing here. I can see, okay, these two have negatives in common. I can cancel those out. 5 times 1 is just 5. And now I just have 5 times -3, which is -15. So I can see right away that I'm still going to have one negative left over. And then 5 times 1 times 3 is 15. So that's a way to kind of get through some of the multiplication a little bit quicker as well. I want to take a moment here and just do some exponent examples. As these kind of always tend to confuse students when we start bringing in negatives. So for instance, let's look at -5 squared versus -5 squared. And you're probably saying they look exactly the same. And they're very similar, except for this one has parentheses. So notice here that the square is touching the parentheses. So this whole thing is squared. So this means that I have -5 times -5. Well, -5 times -5 is going to be +25. Those negatives are going to cancel out. However, so this is touching the whole parenthesis. However, on this side, I don't have parentheses. So that 2 is only touching the 5. It's not touching the negative. Here, my negative was in parentheses, so it was covered. But here it's not. So what happens is you have a negative, and then this part becomes 5 times 5, which is 5 squared. So my answer here instead is actually -20. Okay, let's do another one. All right, so same thing. Notice how that square is touching the whole parentheses. So the whole thing gets multiplied out, and you end up with -4 times -4, which is positive 16. Over here, I do not have parentheses, so this negative just tags along, and then this is just 4 times 4, which is 16. So my answer here is -16. Okay, let's do another one. So -2 cubed, again, I have parentheses, so the whole thing is cubed. It's -2 times -2 times -2. Remember, the exponent tells you how many times to write that out. So -2 times -2 is positive 4, and then positive 4 times -2 is going to be -8. Here I do not have parentheses, so this negative just kind of tags along, and then I have 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. This is 8. So my answer here is negative. Okay. So what's going to happen is sometimes it's going to make a difference in your answer, and other times it's not. When it makes a difference, the parentheses, is when you have an even exponent. So when you have an even exponent, all the negatives cancel out, right? If you have 2 negatives, they cancel. If you have 4 negatives, they would cancel. 6 negatives, they would cancel, etc. So you're going to notice that on your even powers, those parentheses are going to make a difference, whereas on your odd powers, they're not going to make a difference. But you still want to be really careful there. So just watch out for those parentheses versus non-parentheses, because you have just different rules that are happening. So different things are happening, which is why you have the different sign changes in some of the cases. I do want to make a couple comments about the number 0. And I'm just going to do with some examples. So when you multiply with 0, you still just get 0. So it doesn't matter if you have positives or negatives. So for instance, if you have something like -4 times 0, you still get 0. Or if you have 0 times -5, you still get 0. So the multiplying with 0 isn't going to change anything, whether it's positive or negative, you're still going to get 0 as your answer there. If you have 0 divided by a non-zero number, then you still get 0. So for example here, if I have 0 divided by 5, I get 0. If I have 0 divided by -7, I still get 0. Doesn't matter if you're dividing with that positive or negative, you're still going to get 0. Don't forget though, a number divided by 0 is still undefined. So for instance, if I have 6 divided by 0, this is undefined. Or if I have -10 divided by 0, this is still undefined. So it doesn't matter here if it's positive or negative, that 0 cannot be in the denominator. So again, just watch out for these little things that we have already learned, but now that are coming still into play with the negatives. So when we're learning math, everything we already learned should not be thrown away or changed. We should be building on it. So if we had these definitions already about what happens for division with 0 or multiplication with 0, they're still going to hold here even with the positives and negatives. Okay. All right, let's just do a couple more examples. So let's evaluate x over y plus 3x for x equals -6 and y equals 2. So I'm going to let anytime I see an x be -6, and anytime I see a y be +2. And again, I'm just going to use my parentheses here when I plug things in. And it just kind of reminds me how to deal with everything. So for instance, 3x means 3 times x. So I'm going to multiply there. Now you do want to use the order of operations. So I do have division and multiplication. I'm going to work left to right here. So this first part I'll do here. So this is -6 divided by +2. Negative divided by positive is still negative. So it's going to be -3. And then here, I have a +3 times a -6. Again, positive times a negative is still going to be negative. So -18. And now go back to your adding rules. A negative plus a negative stays negative, and I add them together. So I have 21 here. Okay. So this is where it starts getting tricky, and you really need to be careful, is students mix up the different rules. So you have one set of rules for adding and subtracting, and you have a totally different set of rules for multiplying and dividing. So for multiplication and division, excuse me, when you have two negatives, they cancel. But that is not the case for adding or subtracting necessarily, right? So for adding two negatives, it stays negative. So you want to really be careful here. One set of rules for adding and subtracting, a totally different set of rules for multiplying and dividing. So this is where practice is really going to be important, so you have those rules down. All right, and let's just do a couple of real world applications here. So let's say that a professional golfer finished 4 strokes under par. Now that represents a -4 in golf for each of 5 days of a tournament. So he or she got the same score for 5 days. What was their total score for the tournament? So our value here is -4, and we're considering this for 5 days. So there's 2 ways you can do this. One way is you could take that -4 for the score, and you're going to multiply it by the 5 days. And then we'll see that we have a value of -20, right? 4 times 5 is 20, and I have 1 negative, so it's going to stay negative. Another way to think of it is you do have that keyword total. Total means to add. So you could also think of this as -4 plus -4 plus -4 plus -4 for each of the 5 days. And you'll notice that when we add, we keep the sign for the negative, and 4 plus 4 plus 4 plus 4 plus 4 is 20. So either way, you get the same answer. It's kind of cool because we talked about how multiplication was just repeated addition, and it still works with negative. So it's still the same definition that, multiplication is just repeated addition. All right, so let's say that over 5 days, you withdrew a total of $100. How much did your account balance change on average each day? So think about this. We've done averages before. So remember, your average is when you take the total sum and you divide by the number of items you've added up here. Well, in this case, they've done some of the work for us. So here, my total is $100 and the number of days is 5. So your average is going to be divided by 5 for the 5 days. Now we do want to be a little bit careful here because we are withdrawing money this time. So if you're withdrawing money, the change in your account is negative 100. So our total is actually going to be a change of negative 100. Actually, we'll write that in black so it's easier to see. And we're looking at negative 100 this way. Now, a negative divided by positive is going to be a negative, and 100 divided by 5 is 20. So the account changed by negative $20 each day on average. So just a couple little applications here that you can do with sign numbers. Sometimes we forget how many applications there really are, particularly with division and multiplication. So here are just 2 applications that we can go ahead and do with our sign numbers. Now, in the next video, we're really going to put everything together. So I know I've been doing some examples here or there that have, a couple operations with the integers in one, maybe some adding and subtracting, or maybe some multiplying and adding and so on. But really in the next video, we're really going to be putting all these rules together. So this is a great time to go through, practice, practice, practice. You really want to have your sign rules so that it is automatic. You don't want to be drawing as many pictures. I mean, pictures are wonderful, believe me, but you want to get to the point where you can just do it like this in your head. You know those rules so well that it is just natural. So what I do recommend is if you want to create yourself a little note card or a little cheat sheet, just one sheet that has your adding, subtracting, multiplying, and dividing rules on it for the sign numbers, maybe with a couple of examples of each type. And then just keep that with you until you have it memorized, until it becomes more second nature. So that way you're not constantly flipping back and forth to your notes, or you're not getting things wrong because you don't want to look it up. So make yourself that little cheat sheet, that little note card, and keep that with you until you have those rules down pat.